this past week, we had Greg, who is the VP of operations at Dude Wipes, come on and talk about what they're building when it comes to AI with on the crap team for Dude Wipes. And for those of you all don't know, Dude Wipes produces and sells billions and billions of wipes. They've grown into a very, very large, massive success, and now they are using AI to help them automate parts of their operations. We're going to break down a little bit about what Greg was saying and kind of more of the technical side on AI. And I'm pleased to be joined. I know Pranay was my co-host when we had Greg on. Kam, this is your first time on the pod. Welcome.
Hello, hello.
Thank you so much for joining us. As a recap to first what Greg was talking about, he mentioned in the beginning, because I stupidly said AI, and he said, whoa, AI. It's way too broad when you say AI. What Greg was meaning that we should really be talking about LLMs. So to start us off, what is the difference between AI and LLMs and where we are today?
Cam, you want to take that?
Yeah, I think that people say AI and they mean a lot of things. It's gotten to the point, I think, where most times when people say AI, what they really mean is LLMs, which is a very particular kind of implementation of AI. It's a very particular architecture and a very particular type of that architecture, very similar to if people were saying soda and they really meant Coke Zero. And so this sort of blending of the terms to the point of meaning one when they're actually meaning the other is definitely taking place. I think at some point you just kind of roll with it, and a Kleenex is a tissue, and a tissue is a Kleenex, and you just kind of accept what people are calling it.
I miss the time when AI was Allen Iverson, but I'm dating myself. I think AI is out of it. As a consumer, I'm like non-technical, but as a layperson, when I think of AI, I think of artificial intelligence, which is this entire science or this entire discipline of essentially doing things autonomously and making decisions autonomously. And to me, LLMs, which are quote unquote large language models, are essentially these calculators built on billions and billions of words and billions of numbers and phrases set in certain structured ways that basically allows the LLM to be like, okay, I'm going to read 5 million sentences. So if somebody were to write a sentence based on those 5 million sentences, I can predict what's going to come next. And essentially, based on a question, not only now do I have all of the intelligence of those 5 million sentences because I looked at them, I can take those 5 million sentences, put them apart mathematically, put them together in very many different ways to serve the answer to the question based on what I think the person's asking me. So I think of large language models as very, very sophisticated calculators. If you think of the scientific calculator when it came out in the 70s, it was this genius thing where I could put 1 plus 2 and it knew the answer was 3. It's the same thing with LLMs when you put in a word or a phrase or a sentence and it's guessing where you're going. And it does so from this calculation of billions and billions of words and numbers to give you an answer that kind of looks like intelligence, but it's not really intelligence. And so AI is essentially the ability to do things without you asking it things and just doing it because it's making its own decisions. Whereas LLMs are basically relying on you to give it an input to give you an answer based on a calculation that's done through very sophisticated algorithms, very sophisticated, GPUs and very sophisticated computer models.
So with that being said, going one step deeper, we talk about bots, we talk about AI agents. Greg also talked about the difference between RPA bots, which RPA stands for robotic process automation. What are the different, can you explain what he meant there and why this distinction matters, or maybe it doesn't matter?
I think of this as like kind of a continuum, right? Like you have RPA as the most structured, the most defined. Press the arrow key 6 times and then wait 2 seconds and then type in this set of characters and then move the mouse over here and click. And it's very deterministic. There's almost no randomness. There's almost no room for adaptation.
No creativity.
Yeah, there's no creativity.
So it's kind of like a calculator, if that's fair to say.
Yes, but also the most rudimentary, basic calculator. And then you can stretch all the way on that same continuum to a fully autonomous agent where the agent might have a set of not just, buttons on the calculator, but it might have a set of calculators. It might have a web browser it could go use. It might have calendar access or email access that it can use. And the LLM is not only deciding what next action to take. Should I go and use the email or should I go and use the web browser to solve this task, this autocomplete that as Pranay described, right? It's predicting the next token. Maybe the next token is, oh, I should go use this tool. And then it goes and uses that tool because it sees that as the most likely path to solve for this prompt that it was given, right? And so a fully agentic system is going to be going through that loop and deciding if it needs to do more things or if it is done enough that it can return to the user. And so these are on this like long continuum. RPA probably started, decades ago. True agents in the form that we're seeing them now, that they're actually accomplishing something in the real digital world, probably only last few years.
So I would look at an RPA, which is robotic process automation, as a digital printing press or a digital machine. A digital. So if you think of a machine that produces products, right? You put in an input at one end, and there's a very systematic step of things that happens. You press it here, you punch it here, you move this here, you add this here, this nut and bolt is here, this mold is here, and a lunchbox comes out. So a piece of plastic goes in and a lunchbox comes out. That's RPA in the physical world. In the digital world, it is I give you this set of inputs. It could be a form, it could be a specific form with specific fields. Like think of your IRS W-2, or if you think of your IRS W-9. All of these forms were created in very specific frameworks and structures in the 70s and the 80s so that they were quote unquote machine readable. That machine readable part is the RPA, because if you slide it into a machine, that machine is configured only to read that form and no other form. And you think about an AI agent or an LLM, you can slide in any form. Now it looks at the form and then it essentially analyzes all of the fields on the form. And then it goes back to the billions and billions and billions of tokens it has and says, what form have I seen this before as? And then basically figures out what form it is, and then processes it as that form. That's the difference between RPA and LLMs.
That's helpful. I mean, it seemed like Greg was saying how Diesel Dan was more of like a RPA bot rather than like AI agent in terms of what it actually does. How do you both think, in the context of MFD, think about building, bots and agents and the different kind of when it actually makes sense on the spectrum if one of these tools should behave maybe more like a bot versus an agent, and also maybe even developing that trust with the agent if you are building something that's more on that spectrum.
Yeah, it's like basically, a soldier deciding whether they want to follow your order or not follow your order, right? Some soldiers are not given the option, and lots of them. I mean, we've seen A Few Good Men. It's like a whole movie you can watch on whether it's an RPA bot or an AI agent.
I think that this was interesting because I've noticed this in my technical career that things felt even magical or complex or difficult or kind of amazing that engineers could build something, right? And so that's what drew me into engineering in the first place. But then once I understood the mechanics internally, how the machine worked, how the microprocessor or the CPU ended up doing the things that it did, it became like it took away the magic, it took away that luster, that kind of the surprise. And I feel like I lost some of my like wonder or awe, right? And so I heard a little bit in what he was saying was that he realized how internally that he was taking these inputs of data, and sometimes he didn't know exactly what the mathematical function to transform that data input into the plan to pack the trucks, but that he understood it well enough. He started to get close enough into the list of tasks to go about doing it that it didn't feel surprising or it didn't feel magical anymore. And I think that's what a lot of people who build agents right now have this like disconnect because they see the inside of building the thing and they realize, well, 8 of these steps are deterministic and these other tools are deterministic. And the LLM is just a calculator, as Pranay says, right? It's just a really big calculator crunching a lot of numbers. And so at some level, it's doing the thing that you would predict it to do. And so there's a little bit of the gloss that is lost, right? It doesn't feel like magical. Um, but in the end, it behaves in a way that is still surprising to the person who doesn't understand how it works inside. And I definitely have that feeling of like the external to the internal and feeling like it's totally different. Um, that how do I think about when to make it more of a bot versus when to make it more of a an agent? Some of it is like you can think about it on the input and the output side. Like, do I want a human style interface on the input? Do I want somebody to Slack the agent and be able to describe something to them? Well, that input is done really well with an LLM. Now, if I'm getting a computer that's talking to whatever this system is, okay, well, maybe an LLM in between there isn't actually going to help. I don't need that flexibility of human language. And then on the output, maybe the system produces some report, but I don't want to just produce some big spreadsheet. Maybe I do want to produce a big spreadsheet, but maybe I want to describe what I've done. And maybe then, again, I'll run it through an LLM so that the person who's reading it can look at the human language output. And so if a human's consuming it or if a machine's consuming it downstream, maybe I don't need that LLM at the end. That's some of the frameworks I use for like how to think about RPA or bot level versus more agent.
That that makes sense. How do you think about when you think about maybe the bot level um, versus the agent? And of course, this is a spectrum. Maybe there could be some that's in between. Um, but when you think about different use cases and building bots and agents for different companies, right? At MFD, what's your approach in terms of should what I'm building it be more like a bot, a bit more like a specific task it has to do, like it's, kind of just like a calculator or um per se versus an agent which is a bit more autonomous per se that they actually I like your analogy, Pranay, if you're going to build, maybe a soldier doing one specific task like a bot versus, versus a captain. And you actually maybe are navigating maybe some of the strategy. How do you think about that per se as you're building and helping companies solve their own tasks?
Yeah, I think if you think about it from like as a business, as a CEO of the company, as a product person working with Cam day in and day out, I think about it as filing flight plans. Like if you're flying any plane, you need to file a flight plan because you need to know where you're headed. Now, some cases, you know exactly which airfield you're headed and how you're going to get there because you've got to stay in a certain zone in a certain area and you cannot hit other planes along the way. And in some cases, because you're flying in, unrestricted airspace, you could basically decide what kind of, flight zone you're going to take. And so to answer your question, it's not just the outcome that has to be predictable, it's the constraints on how you get to the outcome and the speed at which you get there. So 9 times out of 10, a deterministic bot, which is like, hey, here's a form, figure out the form and take the data and put it into the system and then make sure that the information from the system gets to this person has to be predictable and it has to be in a certain structured way. Those are more bot like, and there are pieces of that you could put into an agent. But then there's certain places where you are essentially going to the agent to essentially say, tell me the best way to do this. And so when an agent is filing a flight plan that says, here are the 5 routes to get to this destination, and you've got to pick routes and you've got to narrow them down depending on weather, depending on the distance, weather, depending on gas consumption or whatever it is. That's an agent. When an agent has many ways to get to an outcome, a bot has just one way to get to an outcome. So it's not just the outcome, but it's also the way you get there. And the agent actually exploring 5 ways simultaneously cuts down on the amount of work a human has to do, cuts down on the amount of processing a human has to do. And a human can take very key decisions across any one of those paths, and then it becomes a bot and gets it done.
I think early on in our building journey, we experimented with sort of trusting in the LLM, for lack of a better term. Um, and we found that without constraints, oftentimes we get unpredictable results. And so if it's too constrained, like Pranay says, that like then you're only going to have one path to the outcome. There's only one way you can draw the line between those 2 points. So finding the balance and building the tools that allow for the variability and the creative fitting, or the kind of I think of it as shock absorbers, right? Like the play, the movement in the system, while at the same time constraining that a little bit so that you know you can keep the agent within some set of boundaries while it's achieving or getting to the outcome, achieving the goal, getting to the outcome.
How long do you find, Cam Pranay, it takes to figure out what those exact constraints will be that actually then produces having enough creativity where that it isn't, there isn't too many constraints, right? But at the same time having constraints so you don't just so you also don't produce, or you also don't do, the wrong thing.
This is where domain expertise matters so much. This is where business expertise, without being dogmatic, matters so much, because you start from the outcome and then you work backwards, because you say, here's my input and here's my outcome. Now, based on the outcome, I am going to see where the agent makes decisions. Now, this is the brilliance of the technology manufacturers built, is you can actually see the decision tree and the path the agent is taking at every point of of the actual workflow, to see how they take the data they get, what do they actually process it into, what decisions are they taking to get to that outcome. And if they're making bad decisions along the way, or the wrong decision along the way, it is essentially an effect of not just the data they're getting, but also the prompts they have in terms of decision making, which is, when you get this data, you've got to think like this, and when you think like this is how you go forward. Those kinds of information are normally hidden either in the model in the LLM side, or they're hidden by, okay, just do this, and there's not enough information to break it down. So by creating that fine tuning of the actual process, you can determine how creative you want the agent to be, or how deterministic or how non-creative the agent needs to be.
Yeah, let me give you an example that I think was a really powerful case of this. We have somebody internally who was trained as a lawyer, and we were building an agent to help review documents. And so it was a reviewing an NDA, is something that they've done hundreds of, maybe thousands of these, right? Um, and all of these documents are reasonably have the same, 5 to 7 kind of key bullet points. And so I described the framework, I showed him the framework, I talked through what, our use case was going to be. And then I asked him to write up what he cares about and what he wants the agent, write it up as if you had a paralegal that was going to go review this NDA, and go about, write this prompt. He was able in one sitting, just sit down top to bottom, write through and describe what are the metrics he wants to look at, which one's high, medium, and low risk, how he would score certain things. And he was able to just immediately, because he understood the variability, he was an expert in the field, right? That was a easy one shot, like one meeting, we were able to build that agent. The agent has now been able to, review all those NDAs since then, right? Now, in a more varied situation, on receiving emails from customers or leads, and they're talking about different things and different product lines, and there's all sorts of different variability about their form of communication and what they're actually asking for and the terminology, and trying to qualify those leads, is there's a lot more spread of variation. And so it took us longer to find how the shape of those dependency graphs flow through the agent, the decision trees, so to speak.
No, that's helpful. That's helpful. So when there is more variance, takes makes sense. Takes a lot more time in terms of how to actually maybe train and because there's also more creativity as well that kind of leads there, right? With it. So it's figuring out what those constraints are because it seems like in the law case, you actually can have, quite a lot of constraints. It's kind of a little bit more nuts and bolts per se. Um uh, I guess getting back to Greg. Sorry, I got way off topic. Getting back to Greg. He talks about one of his first big hurdles was getting the data in the right place. And what does that and he mentioned, for example, like integrations and integrating with NetSuite can be difficult. And this is not like a call out to NetSuite, but integrations in general can be difficult. Why are integrations so challenging or so hard?
Currently, I think it's because most systems are built up over time and they haven't gotten a lot of usage, or there's been so much um, they've they've had such a high hurdle of need for people to connect to these systems that they're spending hundreds of thousands or millions of dollars to connect to these systems. And so they become such a specialized thing. They're not a connection that every consumer could understand and use, right? You need specialized knowledge, you need specialized tooling, you need to get on the phone with them and talk through it. And so it's been in the realm of people who make six figures or more to be doing the integrations, writing the special code that connects these things together, and then they need to talk so that they can understand what the other person meant by some word or some other um, and so that's why like the actually plugging these systems together has been so painful in the past. Things have gotten better over time. It's better now than it was 10 years ago. It was better 10 years ago than it was 20 years ago, but it's still very expensive to plug these data systems together. It's still a fundamental challenge in computer science.
Let me tell you something in a simple way. Like, let's say you have a computer and you're used to naming files a certain way, right? I have a computer and I'm used to naming files a certain way. If my computer wants to talk to your computer, I need to get a file from your computer. I need to first understand how you name files on your computer. I've then got to know where you store those files. I've then got to get permission to go get those files from you. And then I've got to ask for the exact file, the exact way to get files from you. And if I wanted to add a file to your computer, I've got to put it in the exact folder with the exact name, the way you want me to do that. That's an integration. And for that, I have to get all of the information about your system. I've got to understand how you name your files. I've got to understand that if I store files, I store it in the right place so that when your computer, somebody accesses your computer, I have placed files in a way that they can view it. That's an integration, and that takes forever because I have got to be able to read your file system and then write information to your file system while people look at your file system all the time. MCP might solve it because I can then use natural language and then you use the translation layer. Because, for example, I'd be like, hey, Mike, I need that presentation that you did last week for, I don't know, XYZ company. And you're like, okay, let me go look for it. So you'll go into your file system, look for XYZ company, you look for the presentation, the way you stored it, and then you'll just send it to me. That is MCP because I just asked you in natural language for that file. I didn't have to know the exact file name. But until that happens, I've got to build an API to your file system to know your file names and everything. And that takes time and money because that's a development problem.
Can you go over? I'm glad that you brought up MCP. Can you go over what actually MCP means? And I know that in Greg's podcast episode, you mentioned how they're coming out. I remember Kim and I were talking about how Anthropic, they're released on Anthropic, I believe, and then they're very, very kind of popular within the open source community. But just tell me a bit more about what MCPs are. Are they going to be why they're important, and are they going to be a game changer when it comes to LLMs?
I'll tell you, MCP is just one person's opinion of what this technology is going to look like. But the real technology, which is just asking a computer for a file in natural language, to me, is going to be everywhere the more AI agents exist. But can answer a little more about this.
Yeah, I think the quote on MCP stands for Model Context Protocol, which probably doesn't help. Um, But on their website, they say, oh, Model Context Protocol is like the USB-C connector for agents, which again, I'm like, does anybody even sort of understand that? Um, the simplest way to think about it is like that if you wanted to plug a computer into a printer, you could use this connector, this USB cord. And if you wanted to plug a phone into a printer, you could use the same cord. And if you wanted to plug a computer into a phone, excuse me, into a phone, you could use the same cord, right? Like that the way that they plug together is trying to take one thing and make it more standard. Um, they're trying to, instead of in using Pranay's analogy on like two computers talking and figuring out which file systems, at least they're using the same file naming system and the same structure of folders, right? It still doesn't say how do you store the data inside the files, right? It doesn't change that. It doesn't answer any of the are you authenticated? There's all sorts of problems still there. There's still a lot of other problems that it doesn't solve, but it solves this one piece of are we more easily able to connect together and at least understand what files you have on your system? And can I look at them and see if one of those files might have the data I want on the reading side, or are there places that I could write this data that I wanted to send you? So hopefully it makes things easier. I think it seems like it is right now. It's creating all sorts of other problems. A lot of companies are
Let's put it this way: 80% of the communication or 90% of the communication in the world is missed because people are calling different things. That's why you have standards in place, which is like, if I say invoice, you understand what I mean because you know what an invoice means and I know what an invoice means. But when a machine is talking to a machine, one machine may call an invoice a bill and another one may call an invoice a payment or an order form, and they don't actually understand what an invoice means between each of them. However, if you have two AI agents who have been told, go get this bill from this system, and one person is told it's an invoice, is an order form, and one person is told it's a bill, they could go talk to each other, says, I want a bill. Oh, we don't have anything called a bill. We have an order form. Oh, I don't want an order form. I want a bill. Here's what it looks like. Oh, are you talking about an invoice? Yes, I'm talking about an invoice. Okay, an invoice, you have to go make this API call to this system and you will get that invoice. So one agent went in calling it a bill and figured out it was an invoice from the machine system and then got the invoice out. The other one went in calling it an order form, but it was called an invoice in that actual system. And so it negotiated with the system and pulled out the invoice by actually asking for something that the host system didn't actually understand. MCP is essentially a layer on top of APIs that allows agents to talk to systems in a very, very natural language way to pull out their API system to get it done. So if you wanted to talk to a Dropbox system, or you wanted to talk to a Google Drive system, or you wanted to talk to an Adobe Photoshop system, and you didn't need to understand what Adobe was doing, you could just be like, hey, fetch me that image file from this database, and MCP would allow your agent to talk to the system and pull it out by an API call that the system will honor without you having to know any technical information.
Do you think that these companies will actually implement MCPs or not?
there's I think this MCPs are creating an interesting challenge to incumbent SaaS companies because if they implement MCP servers and they allow all of their users to access, be all of their data to be accessed through an MCP server they host, it could erode the value of their per seat pricing. um, it could mean that they don't have the same pricing power, right? So that might lead them to say like, oh, we don't want to run this MCP server. We don't want to host this server ourselves, which then leaves them open to somebody else writing an MCP server and then connecting against their API. And then that third party now becomes, do you care if that SaaS company is behind the MCP server? No, you care about the business outcome. That is the document getting signed, or is the document getting stored, or is the invoice being delivered, or am I tracking my inventory? And so I think that incumbent SaaS companies have a challenge right now of they're not sure if they want to stop and not do it, or if they want to go and launch one of these servers and they're caught in the middle right now.
I think that on a long enough timeline, you're either going to embrace an open system or you're going to die. However, in the short term, if you want to maximize profits and you are a publicly traded company like Salesforce is, you will turn off the Slack API and not let anybody build on top of Slack. Or you will, if you're X.com, you turn off the X API and start charging for it because people want access to your API. It's relative to the value of information you have in your system and how much you want to charge for that system. And then how easy do you want to make it for people to access information from the system so they can make money. So if you think that I'm making money from your system and from your platforms, and you think that getting MCP makes it easier for you to make money off me, and if I am charging you $10 and you're making $100 every time I send you $10 worth of stuff, then I want to make it as hard as possible for you to come in on $100 worth of stuff, and I want to start charging you 25. And so to do that, I make it difficult for you to just pull in data via MCP on a long enough timeline. I might die as a company because I'm stupid because I just restricted the amount of people coming in, bringing data back to my system. But whether it is natural language, I call MCP a natural language API. A natural language API is I just ask a machine in natural language what I want. It figures out where in the system it sits and it gets the data back to me. Now, whether you think of it as API system or a natural language system, to me, usage driven pricing is the future of any computer system. And if you manufactured, we charge for outcomes. We don't charge for inputs. So we don't come to you asking you for a subscription fee. We basically be like, let's be revenue share partners. Let's succeed on this together. We'll take a percentage of whatever we succeed at and grow together. That basically is where the whole world is headed. That's where Anthropic is headed. That's where OpenAI is headed. That's where all these companies are headed. And over a period of time, this whole tokenization of actual data will make everyone get to that API system. But in the short term, you're going to see a lot of people fighting.
Thanks for that. That's also just really helpful when it comes to integrations. Well, he also just speaking about integrations. He mentions that he uses Make.com, and he mentions that's a beefier version of Zapier. What's the difference? How should you think about it between Make.com, Zapier? There's also N8N, there's Pipedream, there's Lindy. How do you think about all of these different products?
I think of them reasonably similar. Like they have very similar use cases, very similar kind of workflow builders. They're all trying to add, type in your prompt of what you want to build, and we will build this workflow diagram for you. They all want to add AI in as little nodes in the workflow. So they all feel very similar in my mind. I've not been like a deep production system user of these things, but I've used them for smaller items. And like fundamentally, they all feel like that same sort of not quite agentic, but a little bit more on that RPA bot side of things that I need to wire in. I, as a user, need to understand how to plug these two things together and how to make one of them go into the other and how the process should work.
That's helpful. Anything more to add, Pranay?
Look, if you're a layperson and if you use Zapier, you know that, for you to be able to hook systems together and make them do what you want them to do in a defined system sequence is really hard. And so all of these things, Make.com and N8N, are really, really useful at just adding an LLM to those systems. So either they've got all the integrations done, or they allow you to basically create a system. So they're creating what we call RPA bots with a very defined flow that still uses an LLM, but actually gives you a straightforward outcome. So any one of these things is not going to help you actually autonomously run an entire structure. But what they will do is essentially create many small items. So scan this document, add this email, integrate this calendar, process this information, receive this information, create this report. Those are individual tasks that N8N can help you or Make.com can help you, and you can stack them one on top of the other. But think of it as a human pulling 5 strings and running a puppet show versus, animation.
Yeah, if you can write down a checklist.
Puppet shows are great, don't get me wrong, but there's somebody pulling the strings from behind. and N18 is helping you build those strings for you to pull the puppets.
Yeah, if you can write down the checklist and give it to an intern, and on their first day with no business context and no knowledge and no understanding, if they're able to run through the checklist and do the process, that probably means it's a business process that is amenable to use one of these systems, right? It doesn't require any judgment or any context about the business or any autonomy. It's just, can I go through this list of tasks and do each of them?
How how also do you think organizations should roll out AI or LLMs in terms of using it as a like Greg mentioned, for example, in terms of adoption and getting his team at Dude Wipes to adopt it. It was to introduce as a tool. This is just another tool that you can use in your toolkit, not something that's kind of forced. How do you think about organizations how do you think organizations should first of all roll out AI, and then secondly, um, you know, uh, interact with AI? Meaning, um, how do you give an agent personality or have it not be as obviously it's magical, but at the same time, you also want to make sure it's not too uh they're still adopting the agent, and obviously an agent doesn't necessarily we're all used to working with humans. We're not used to used to actually working with bots and stuff like that. So how do you kind of humanize as well that experience?
Yeah, I'll combine that with the whole kindergarten teacher comment he made, which was so spot on, and with the prompt engineering question, which was also so spot on. I think all three of those questions go together, which is, how do you actually teach prompt engineering? How do you then generate the patience to train an agent? And then how do you quote unquote drive adoption if people think, oh, this is not going to work. This piece of software is stupid. I think at the end of the day, what we've realized is, and this is something I tell everyone, is when you make AI mimic humans, the tolerance level for hallucination goes way up. When you say, like we have an SDR, AI SDR named Luca, or we have an sourcing SDR named Carmen, we're like, oh, Carmen messed up today. It is a human level of conversation, even though you're talking about a piece of software. So essentially, you're like, okay, I got to go train Carmen on how to fix that problem that she went into and that she actually, messed up on those number of customer vendors she was doing this, or she sent an email out to someone. When you say she, and when you use a humanized version of an AI agent, you've automatically acclimated yourself to, I've got to make this agent better. Now, how you make that agent better and the training of that agent is something manufacturers build technology for, which is very rare in the world out there, because you once every time on an N10 or a make.com, you create an agent and it messes up, you got to tear it down and rebuild it again. With manufactured, you can actually keep improving it and not forget the base level stuff that you send to it. And so you first of all, you need patience, which is, I want an agent to do this job. I do not want a human to do this job anymore. And so I'm going to get to the place where the agent can do what a human does. So it's kind of like training an intern, and you're training an intern so that the human can do better level tasks. So by getting the human to buy into the fact that you are an important human in this company, your work matters, and the work you're doing right now could be automated. And so here is the higher level of work I want you to do, and them getting excited about it is the first step of basically adoption, which is making the humans realize that they are meant for greater things. Actually helps the human elevate above the bot. But the second is then creating the guardrails for the agent to actually do the things the human wants them to do, and measuring output every day until the bot is doing things the human is satisfied with before the human can move on to bigger things. And those three things are basically combined together, and it's a trial and error situation. It is not for every human. It is not for every bot. You have to essentially work together. Like the average onboarding and training time for an agent manufactured builds is about 6 weeks.
That makes a lot of sense. How do you think about this question as well, Cam? In terms of how to integrate AI into companies, and also what kind of we've done at MFD.
Yeah. Well, I kind of have a smirk because we're a software company building AI. So I don't think it's a choice. Um, Everybody must use AI, not from a from a perspective of just like market education. The world is changing so fast. we need to be using these tools to see where they're strong, where they're weak, where they have difficulty, where they surprise us, for the good, the bad, the other. Um, and so I don't think it's a choice that we're using AI internally. We're trying things out. I want my own first instinct, and everybody on my team's first instinct is to use AI. Um, any task. Hey, could I ask some AI tool, not necessarily an agent, but there's lots of tools out there to use, and so experiment with them, use them. It should be part of the daily process. Um, Balancing that with uh, we joke there's some members on the team that like to talk about the work product that they're bringing to the team and asking the team to review. They'll comment that the AI did it. Oh, I had this AI do this. And, we make jokes about that because I also think that although we're reaching for AI first, that I, as a human, am owning the work product. I, as a manager, am responsible for the work product of my team. I, as a human using AI, am responsible for the work product that I am allowing through my filter, right? I am not in the back seat getting, driven around and, oh, well, the driver took me to the wrong location. I am choosing where we're going. I, as a human, have autonomy and am picking, do I choose to did I use the right tool and did it give me an answer that I'm agreeing with and putting my reputation behind? So that's sort of the first piece on adoption and I think your mileage may vary depending on size of organization and you know how technology forward you are. I'm not trying to comment that that's the right answer for every other organization. So, and then the training I think is really, um, I have seen that with training, I have talked a lot about that with AI, we're not getting replaced as humans, but we're all getting a promotion. And what I mean by that is that at any role, there is now an opportunity to manage AI agents that are doing the job you are currently doing. Um, and I've seen this with members of the team that as they were improving and onboarding an agent and getting them to respond in the way that we would expect, with the level of quality that we would expect, they kind of confided in me like, well, what am I going to do after this agent is after we're done, once we you know turn it fully on? And they expressed some concern, and I think that concern had been simmering under the surface. And a few weeks later, I saw them like on another weekly call. It clicked for them that they were like, oh, I'm going to be managing the agents. I am doing a different role now. I have just gotten a promotion to be a manager of these agents, and I'm going to manage this workflow and this process. And I think that shift was really great to see in somebody, and then to have coming from the CTO, it's not really convincing. I think I come in and say like, don't worry, AI is not taking your jobs. First, let's automate your job with AI, right? Like there's I can see the skepticism, right? They go along with it, but they humor me, but I can see there's some hesitancy, and I think seeing that person in our team shift their perspective and really dive in, and then to be able to bring other members of the team along, I think that did a lot for our team internally, to understand and to trust and to see the value in, oh, this is something that's going to improve my work. I'm going to go from spending 4 hours doing some particular task a day to I can spend 5 minutes, and now I can be going and doing other things that are valuable to the business.
Yeah, I mean, it allows people then to do things that they weren't actually able to do before, right? In terms of lost hours, that they can be. And I mean, to kind of your point, Cam, everyone has kind of become managers, right? And that's and as in terms of from like the job promotion aspect, so that it makes total sense. Awesome. Well, I thought that this was a great conversation and also a great recap of some of the kind of terminology that Greg went into on the episode, slash also just talking about AI and LLMs, obviously. Kim, Pranay, thank you both so much for your time.
Thank you.
My pleasure. It was awesome. Thank you so much for jumping on. Appreciate it.